right, 7.6, vertex form of a quadratic function. So we've had various forms. We've had standard form, which is ax squared plus bx plus c. What's nice about this form, there's your y-intercept. You can tell right away if it goes up or down. Then we've had factored form, x minus r, x minus s. What's nice about that? Well, there's your x-intercepts. This times this times this is your y-intercept. Okay, well, what if you don't have x-intercepts? And what if you're not given the y-intercept? Then what if you're given the vertex? So you need a different form. So the vertex form is y equals a x minus h squared plus k. And I'll explain this in a second. So it says to sketch the graph of a quadratic function in vertex form, you're going to start by plotting the vertex. So here's your vertex. This is the x part of your vertex, and this is the y part of your vertex. So that can be handy. And then remember that wherever your vertex is, there's your line of symmetry. So if you have your vertex, you have your line of symmetry as well. Remember that if this a is positive, your parabola will open up. If that a is less than 0, negative, your parabola will open downwards. Okay? All right. So let's give it a try. We have something in vertex form. Okay? It says sketch the graph of the quadratic function of y equals negative 2x plus 4 squared plus 10, and then state the domain and range. Okay, so first of all, we know it opens downwards. It's got a negative 2 in front of it. So it opens downwards. And I know my vertex is at hk. And it's written in the form of y equals a x minus h squared plus k. Well, k is easy. Here it is. It's 10. Now, what do you think about the vertex? It says x minus h, but this is a plus 4. So what do you think that the h has to be in order for it to be subtracted from x, but to end up at positive 4? So hopefully you're thinking, well, it has to be negative 4, because x subtract negative 4 makes it positive 4. Okay, if that doesn't make sense to you, the easy thing to remember is that if it's inside of one of these brackets in parabolas, you always take the opposite. All right, so my vertex is at negative 4. Eyeball roughly where you think negative 4 would be. 10-ish would be up there, and label it. Negative 4 and 10. My axis of symmetry, I'll actually use a line for this. It's right here. Let's move that over a smidge, try to get it, there we go. And if I make it red so it stands out, and you should always label it. So label it x equals negative 4. Okay, so my parabola, this is the highest point, looks something like this. Now to get the x-intercepts, I'd have to expand this and then I'd have to factor it. But I could calculate my y-intercept because I know that when I'm on the y-axis, okay, so to get the y-intercept, and I know I'm on the y-axis, x is 0. Okay, right here, x is going to be 0. So let's see what y will be when x is 0. So y will be negative 2, 0 plus 4 squared, plus 10. BEDMAS says I have to do what's in bracket first. So 0 plus 4 is 4. BEDMAS says I have to do exponents next. So I have negative 2 times 16. Have to multiply. Negative 32 plus 10. Negative 22. So way down here somewhere, that's not even low enough, but whatever. I'm sketching. My y-intercept is negative 22. That means I've got another pair, another ordered pair here. That's also at negative 22 because remember that parabolas are perfectly symmetrical. Do you know what the x part of this is over here? Took 4 spaces to get there, took 4 more to get over. So you have another ordered pair at negative 8 and negative 22. In your best freehand, connect them up, and there's your parabola. Okay, so there's the sketch. Domain. What are the possibilities of x? Hopefully you remember this from before. The domain x can be anything, anything. So you write it, x is in the set of all real numbers. Range, well, we only have one limitation. We have a maximum. So we have a very highest y that this graph can ever be, and it's at 10. So y is less than or equal to 10 would be the range. Okay, there's example number 1. So maybe you like that. Maybe you like it in the vertex form. It's not that bad. Okay, we're going backwards in example number 2. It says, here is the graph. What is the equation? Okay, so we have the vertex, so let's use that. Y equals ax minus h squared plus k when my vertex, 7 and 8, is h and k. So far, I know that y equals x minus 7 squared plus 8. Okay, h is 7, just plug it in. And then k is 8, plug it in. So I'm almost there, I just don't have my a. Okay, but you know what? I have got this nice ordered pair that they gave me here. They gave me a random ordered pair on the graph. So how I'm going to use that is that I need to calculate my a. I know for sure my a is negative because my graph opens downwards. Okay, I know I've got this point P here that's at 4 and negative 1. Okay, any ordered pair that's on this parabola, you're going to be able to plug it into your equation and it will make the equation true. So I have an x here, I have a y here. I'm going to use it to solve for my a. So I'm going to plug in my y, which is negative 1. A is what I want to figure out, although I know it's negative. X is 4 plus 8. Okay, A is what I'm trying to isolate. This is what I'm trying to solve for. All right, MedMath says I have to do what's in bracket first and then squared. So A is sitting there waiting for this to happen. I have 4 minus 7 is negative 3. Negative 3 squared is 9. Now, this might bug you, so just rearrange it. A9 is the same as 9A. Okay, I'm trying to isolate the A. Get rid of 8, get rid of 8. So I have negative 9 equals 9A, divide by 9, divide by 9. A is negative 1. So go back here and finish off, because now you know what A is. Y equals negative 1, x minus 7 squared plus 8 is your answer. You could have just put the negative. You don't have to put the 1 if you don't want to, if you were thinking that. All right, good luck. Give them a try. Come and get help as you need.